This slide returns to the master list and highlights advanced core analysis, including NMR, digital rock physics, rock mechanics, and organic content and maturation. This tells students that core analysis is continuously evolving. Modern petrophysics is no longer limited to classic plug tests. We now use advanced imaging, digital computation, and unconventional reservoir workflows to extract far more information from core than was possible in the past. This slide is particularly important. It shows NMR, digital rock physics, rock mechanics, and organic content, and compares a traditional sandshell model with a more realistic model that includes clay-bound water, capillary water, free water, and hydrocarbons. This is a big conceptual upgrade. Real reservoirs, especially shales, are much more complex than simple two-phase or three-component models. NMR helps separate fluids by mobility and environment in the pore system. That makes it very powerful for unconventional reservoir characterization. This slide appears to be a visual or example slide referencing a distinguished lecturer. Since the text content is minimal, your narration can focus on the broader message. Advanced petrophysics is a very active field with continued innovation in NMR, digital rock physics, and rock characterization. This is a good place to tell students that petrophysics is not old-fashioned or static. It remains a highly dynamic research and industrial discipline. This slide continues the advanced analysis section, likely with a visual example. I would use it to explain that digital rock physics and advanced imaging allow us to reconstruct pore systems numerically, simulate flow, and estimate petrophysical properties without always relying exclusively on destructive laboratory testing. This is especially attractive in difficult or expensive core programs. This slide appears similar and is another good place to reinforce how advanced petrophysical tools support modern reservoir characterization, particularly in heterogeneous or unconventional systems where standard correlations may fail. This slide continues the same section. This can emphasize that organic content and maturation are especially important in shale plays because the source rock may also be the reservoir. In such systems, petrophysics must incorporate geochemistry, pore structure, and mechanics together. This slide introduces CT scanning, which is one of the most powerful non-destructive imaging tools in core analysis. CT scans allow us to visualize internal heterogeneity, fractures, bugs, bedding, and density contrasts inside the core without destroying it. This is very useful because it bridges descriptive geology and quantitative digital analysis. CT data can also support digital rock physics workflows and help select representative plug samples. This is another transition slide in the advanced analysis sequence. I would use it to remind you that these methods are especially valuable in complex rocks where conventional plug tests alone may not be sufficient, such as shales, carbonates, fractured rocks, or very heterogeneous reservoirs. This slide includes a striking quote that petrophysics is an exotic earth science, poorly understood and rarely appreciated in the oil and gas industry. This is actually a very good closing thought. I can tell you that petrophysics often works quietly in the background, but it is essential. Without good petrophysics, reserve estimates, saturation models, flow forecasts, geomechanical models, and even well log interpretations become unreliable. So although it may be underappreciated, it is one of the most strategically important disciplines in petroleum engineering. Next week, we move to well log interpretation. This is the perfect continuation of today's lecture because well logging is where many petrophysical concepts become operational at full well scale. This week, we learned the physical meaning of porosity, permeability, saturation, capillary pressure, relative permeability, wettability, resistivity behavior, elastic properties, and advanced core analysis. Next week, we will learn how to estimate many of these properties continuously from well logs. This slide asks two important questions. What is petrophysics? What information can be obtained from core? A strong answer would be, petrophysics is the science of quantifying rock and fluid properties relevant to storage, flow, saturation, electrical behavior, acoustic response, and mechanical behavior. From core, we can obtain geological description, porosity, permeability, grain density, saturation, capillary pressure, relative permeability, wettability, electrical parameters, acoustic properties, mechanical properties, mineralogy, pore structure, and advanced digital information. Thank you everyone. In this lecture, we moved from the basic definitions of porosity, permeability, and saturation to the much broader role of core in reservoir evaluation. We also saw how routine and special core analysis support log interpretation, fluid flow prediction, and rock mechanics assessment. This is one of the foundational weeks of the course because it gives you the language and physical intuition needed for future topics in well logging, reservoir engineering, and production analysis.